Jai Ram Krishna. Good morning students. In this session I will derive equation of center of mass of a semicircular ring. Here I am taking a semicircular ring of radius r. Let O is the center of the semicircular ring. I am taking a small element of length dl on semicircular ring. Element is small in magnitude. When integrated within the limits gives the total semicircular ring. Let the radius makes an angle theta with the horizontal. Then coordinates of the element are r cos theta and r sin theta. This value is r cos theta and this value is r sin theta. Then since this semicircular ring is continuous mass distribution, we should know that x center of mass is given by integral x dm by integral dm, where x is the x coordinate of the element of mass dm. Here dm is the mass of the element. Here integral dm is capital M, which is the mass of the semicircular ring. Similarly, y center of mass is given by 1 by m integral y dm, and you should remember integral sin theta d theta is equal to minus cos theta, integral cos theta d theta is equal to sin theta, sin pi is equal to sin 0 is equal to 0, cos pi is equal to minus 1, and limits of angle theta varies from 0 to pi. As we know, theta is equal to L by r. Length of the arc dl is given by r d theta, where d theta is a small angle. Now to find mass of the element dm, I multiply linear mass density of semicircular ring with length of the element. As I told in last session, linear mass density of the semicircular ring is given by total mass of the semicircular ring by total length of the semicircular ring, m by pi r. Then what is the mass of the element dm? That is by multiplying linear mass density with length of the element, I get mass of the element, that is m by pi r into dl is written as r d theta. Then x center of mass is written as 1 by m integral x coordinate of the element is r cos theta dm. dm is written as m by pi r into r d theta. On cancellation, we can write integral r by pi. R and pi are constants. I am taking out of the integral. So what remains inside the integral is cos theta d theta, and limits of integration varies from 0 to pi. Now on integration, I get r by pi. Integral cos theta is sin theta. Lower limit is 0, upper limit is pi. Integral cos theta d theta is sin theta, that is r by pi. First I substitute pi in place of theta, upper limit minus sin 0, as sin pi and sin 0 are 0. 0 into r by pi is also 0. I get 0. Similarly, y center of mass is written as 1 by m integral y coordinate of element is r sin theta dm. dm is written as m by pi r into r d theta, and limits varies from 0 to pi. And I take this r by pi out of the integral. R by pi integral 0 to pi sin theta d theta, that is r by pi integral sin theta d theta is minus cos theta. Lower limit is 0, upper limit is pi. To remove this negative sign, I interchange the limits. That is r by pi cos theta pi and 0. That is r by pi. First I substitute 0 in place of theta. Cos 0 minus cos pi, that is equal to r by pi. Cos 0 is 1 minus cos pi is minus 1, that is written as 2r by pi. It means that y coordinate of center of mass lies at a distance 2r by pi from the center of the semicircle on the axis of symmetry.